compound inequalities. A compound inequality is formed by joining two inequalities with the word and or. So you have to know which is which one is and, which one is or. So in these examples, when I say x is greater than 3 and x is less than 5, or I could sometimes say 5x minus 3 is less than or equal to 7, or minus x plus 3 less than or equal to minus 5. So you have to understand what is the difference between and or. For any two sets of numbers, like if I have two sets, set A and B, the intersection of these two sets, we use this symbol here for intersection, is defined as and. So if you want to find the intersection of two sets, you're going to say and. In other words, you want to know what do you have in common between two sets. What do you have in common between two sets? You use and. So in this set, in this example, if the set A consists of these elements, 3, 4, 5, 6, and set B consists of 5, 6, 7, intersection of these two sets, or A and B, would be 5 and 6. So when you talk about and, means intersection. So let's take a look at this example. Now we know and means intersection. If I were going to solve x is greater than 3 and x is less than 5, we can graph these individually and then take a look and see what these two graphs have in common. So you see all the numbers between 3 and 5, but not including 5 because 5 was not included on the endpoint here, and not including 3. That would be the intersection of that. If I were going to write this in the interval notation, I would write that the answer would be all the number between 3, 5. That's how you write the answer. So and means intersection. Let's take a look at some more examples here for and. Here we have two sets, x plus 5 less than or equal to 8, and 2x minus 9 greater than 7. So in this case, we're going to solve these individually. Here I'm going to subtract 5 from both of the inequality. I get x is less than 3. Here we're going to add 9 and divide both of the inequality by 2. Then I would get x is greater than 1. I'm going to graph these individually and take a look and see what do you have in common between these two sets. As you see, would be all the numbers between 1 and 3, not including 1, but including 3 would be the set of the solutions. So if we're going to write this in the interval notation, I will write this as all the numbers that are in between 1. I'm not going to include 1, so I'm going to use the parentheses, comma, 3. 3 is included. I'm going to use the brackets here to show my interval notation. Finding the union and intersection of two intervals. So in this case, we want to know what do we have in common between these two intervals. Negative infinity to negative 2 and negative 4 to 3. So let's go ahead and graph these. Negative infinity to negative 2 would be all the numbers from negative infinity to 2, including the 2s. I'm not going to include the negative 2, so I'm going to use the parentheses here. And then for the next set, would be all the numbers between negative 4 all the way to 3, using a bracket for negative 4 and then parentheses for 3. So what do we have in common between these two sets? We can clearly see that all the numbers between negative 4 and 2 would be the solution, and that would be the interval notation for that. Here's the example with and again. X is greater than negative 3 and x is less than or equal to 2. We can graph each of these individually. X is greater than negative 3 would be all the numbers to the right of negative 3. X is less than 2 would be all the number to the left of 2. What do we have in common between? Because it's and, would be all the number between negative 3 and 2. Interval notation would be parentheses, negative 3, comma, 2, brackets. We're not going to include negative 3, we're going to include 2.